All right, this is a reteach of solving logs. If you haven't seen this before, this video might not be enough, but if you've seen solving logs before, then this is just kind of a rekindle of it, because I don't want this video to be gigantically long. There are two kinds of solving log equations. The first is when log is already equal to log. These are the easiest, although they tend to look a little weird to start with. Sorry, we have a cat in the room that is convinced she needs to make as much noise as possible. These are really nice because when the logs are already condensed, which they usually are, you introduce a base in order to cancel the log. Sorry, now the dog's mad that the cat is making noise. Anyway, you introduce a base to eliminate the logs, and then you just solve the equation. So the first step for this is condense each side if you need to a single log. It does occasionally happen where you have more than one log on the left side and only one log on the right, and so you have to condense here. Condense, you need the properties, and I have a video for that about properties of logs. Come on, sorry, more animal stuff. But for us, for this particular example, because this is a single log equal to a single log, I don't need to condense. All right, and I'll show you how to condense, or at least I'll remind you how to condense with the next example. The next thing that I do is I introduce the base to set each log as the power and eliminate. So I look at my logs and I say, what is my base? My base on each log is 12, so I'm going to take 12. This turns 12 into a base, and then this whole thing becomes a power. Because of the properties of logs that lets us pull powers down to the front, we can eliminate the 12 to the log 12 because they're inverses of each other. And then what we'll have left is just that x minus 6. So what happens is, because this is 12 to the log 12 power, and because this is 12 to the log 12 power, this reduces to 1. I'm left with x minus 6. On this side, reduces to 1, and I'm left with 3x minus 18. Now it's an Algebra 1 style solving problem where I want to collect my x's on one side and my numbers on the other. I'm going to collect my x's to the larger x, usually, so I'm going to subtract an x on each side. Remember, that's an invisible 1x. Woo! That was a terrible one. Awful. Here they reduce. You're left with negative 6. 3x minus 1x is 2x. And we still have minus 18. Now I'm going to collect the numbers to the same side, so I add 18 to both sides. 18 minus 6, I believe, is still 12. So 12 equals 2x. I divide both sides by 2, so x is 6. So what you notice, hopefully, is when log equals log, you really introduce the matching base, they eliminate, and then the problem is a straightforward solving problem. If there's more than one log, you have to do a little more work, and usually what happens is you usually have logs on one side and not the other. So that's the next style we're going to look at, is what happens when you have a log on one side and the other side is a number. Okay? I'm going to just make a number up, a problem up, so it might not come out perfectly, but you can always use a calculator if the numbers are going to be weird. All right, I'm going to pause for a moment. I've just been teaching so long today that for a second I was going to be like, okay, everybody have this one written? There's no humans here writing this, so. All right. Condense each side to a single log, introduce base to get each log as a power and eliminate, and then solve. The next problem is going to be exactly the same, but we're not going to introduce it to set each log as a power. We're going to introduce it to set each side as a power. And then we eliminate when it's possible. Woo, squish that in there. So it's really the same steps. The difference is we're not going to get an elimination on the right-hand side. So I'm going to go ahead and erase this one. The next style is going to be when log is equal to a number. Oh, sorry, cat. And it usually has to be condensed. I don't know, log base 4 of 3 plus log base 4 of x plus 2 equals, I don't know, 4. Okay, well, let's not choose 4. That way it doesn't mess your brains up when it, let's do, the number was going to get too big. All right, I don't know that this is going to work out evenly, but that's okay. We're not scared of fractions, are we? Okay, so I'm going to condense each side to a single log. You need log properties for this, so if you're having a trouble with log properties or you haven't seen log properties, you're going to have a heck of a time. On the left-hand side, because I have two separated logs, they're both log base 4, and they're separated by a plus, I'm allowed to use the product property and condense them back to a single log. When I do that, what happens is, because it was a plus between them, they now squish back together and become a multiplier. Okay? Now, I can send that through right now. I can wait to get rid of the log to send it through. It doesn't really make a difference. I'm going to send it through now just so you see it. So now I have log base 4 of 3x plus 6 equals 2. Now I'm going to do the same second step. I'm going to introduce a base to each side, but what's going to happen is the log on this side will eliminate, the number on this side will become a power, and we're going to end up with a slightly bigger number on the right-hand side. All right, because this now becomes our power. So when I introduce 4, I get 4. Log base 4 of 3x plus 6 becomes a power, and then I get 4 to the second. Okay, on this side, the 4 to the log 4 is going to reduce to 1. Then I'm left with 3x plus 6 equals 4 squared, because those don't cancel, they're not opposite operations, and 4 squared is 16. Okay? Now, I'm going to solve it like a regular solving problem, and it's going to get a little squished down here. I might finish it up over on this direction, or maybe over on this side. This is going to give me 3x equals 10. I divide both sides by 3, and I get x equals the fraction 10/3. If you hate fractions and want to turn it into a decimal, you certainly could, but notice I still condense each side if I need to, which I didn't in the last example, but I did in this. I introduce the base just like I did before. The only difference really is because there's only a log on one side, I only get elimination on one side. I still have to remember to take the base to the power on the right-hand side so that I know that this 2 is still being treated equally. Remember, it's still an equation. If I take and I make this a base of 4, and I don't make this one a base of 4, what happens is I've just made this one bigger, and it's now heavier, and the balance is broken. Whereas if I introduce a base of 4 on this side and a base of 4 on this side, it might look a little wobbly at first, but they even out because I've done the same thing to both sides of the scale. All right, once I get rid of that, it now is just a solving problem. Don't forget to take your base to whatever your power is and solve. Okay? So once again, if you have more questions, you can always, if you have me, you can always ask them in person. If you don't have me and you're watching this video for some reason, you can always leave a comment if you have questions. This isn't really all of the log equations, but this is for me, for my class right now, sort of the extent of what we cover. All right, I hope that was helpful, and I hope you have a lovely day.